compressed air used in pneumatic circuits must be clean and dry. Let's examine the devices used to produce compressed air. Compressed air can be produced using stationary or mobile compressors. Both types use various designs to compress the air into a smaller volume. Two of the most common types are piston and screw compressors. The drawing on the left represents a reciprocating piston compressor. When the piston moves down, it draws air into the cylinder. It then moves up, compressing the air. Compressors that contain one cylinder are called single-stage compressors. Each stroke of the piston produces a burst of compressed air. The screw-type compressor consists of two threaded shafts that are intermeshed. As they turn, they transport air from the intake side to the compression side. One advantage of this type of compressor is that it produces a continuous flow of air. In both types, as the air is compressed, energy in the form of heat is concentrated in a smaller space. So, most compressors include a cooling unit to reduce the temperature of the compressed air. Such units can also be used to reduce moisture, oil, and dirt in the compressed air. The compressed and cooled air is then stored in a tank called a reservoir, which performs several functions. It acts as a buffer, smoothing pressure fluctuations as the air is used by the circuit. This also allows the compressor to run only when needed to pressurize the reservoir. The reservoir also supplies a steady flow of air to control circuits. This reduces fluctuations in pressure under varying rates of use. In addition, the reservoir helps to cool the compressed air. As the air cools, moisture separates from the air and collects in the bottom of the reservoir. This water must be drained from the reservoir on a regular basis. Not all of the moisture is removed in the reservoir, so in order to prevent corrosion of valves and other components, a dryer is often included in the system. When designing and installing a compressed air system, the distribution of the air has a major effect on system performance. The size and layout of the pipes is critical for economical operation of the system. The design should also allow for future increases in demand because modifications can become very expensive. Connections to the main piping should be done from above to prevent water from flowing into the machinery. The system should also include fixtures that allow water to be drained off.